This is a very popular gate problem on operational amplifier with a T-type feedback topology. And the question is that we have to find out the voltage gain, so V0 divided by Vi for the circuit shown here, and assume that all the resistances are equal and the op amp is also an ideal one. So with this problem, we take this to be one of the nodes and this one to be the other node, and then frame the nodal equation. So the first point is that voltage at this node will be equal to Vi because of virtual short, and then if we assume that some current I1 is flowing through this branch, and if I2 is the current that flows through this branch, then I1 must equal to I2 because the op amp is drawing no current through its input terminal. An op amp offers infinite input resistance, and therefore zero current will enter the input terminal of the op amp. Therefore, if I1 and I2 are same, then we can frame the expression as 0 minus of V1 or Vi divided by R, which is the current I1, and it should be equal to this current, which is given by Vi minus of the voltage at this node. So we can put a node voltage like Vx over here because this is unknown to us. So we can write Vi minus of Vx divided by R. So this is the first equation, and so transforming it into this Ohm's law form results in the value of Vx being 2 times that of Vi. So the voltage at this node is equal to twice that of the voltage which is applied to the non-inverting input terminal of the op amp. Next, somehow we have to eliminate this Vx, and therefore we need one more equation, and so we consider this to be the second node and then apply KCL to this node. So we find that this current I2 should be equal to I3 plus I4, and therefore we can go ahead with the formulation as with I2 we can write this as Vi minus of Vx divided by R. For I3 we can write Vx minus of 0 divided by R, and for I4 we can write Vx minus of V0 divided by R. So we go ahead with plugging these terms in the I2 is equal to I3 plus I4 KCL expression, and then from here we obtain V0 is equal to 3 times Vx minus of Vi, where the value of Vx can now be substituted, which is equal to 2 times Vi. So once we make this substitution, we obtain the value of V0 as 5 times Vi. Now, because the question is asking for the voltage gain as the ratio of output to input voltages, therefore V0 by Vi is equal to 5.